So it's been a while since I posted the overview video, which did surprisingly well. I wasn't expecting that many people to watch it, but I'm really happy about it. And I didn't really get the chance to edit the rest of the video clips that I had. So I have a bit of free time now with school, and I'm hoping to kind of churn out these videos. This video will be a little more in-depth, looking at some initial design considerations, tools, and planning that I put into the project. It'll be a bit of a longer video, so please feel free to skip around. So this is a bit of a crude assembly that I made in SolidWorks. I always had some ideas and sketches of how I was going to design the system, but once I actually got the rain barrels from that yard sale, I kind of started to finalize my design, and this is what I came up with. Just for a brief overview, from the top you can see the slow, and from the side view you can see the two sweeping bends, goes into the radial flow settler, and then from the top view you can see the standpipe, and to the right of it we have the pipe that feeds the water down into the sump, and that water is pumped back up into the grow bed and pumped back into the system. So I've already started to kind of get all the materials that I've needed, or I plan to need. A big thing that I had some foresight to take a look at was the 90-degree elbow joints. I did some reading online about the amount of friction that these straight elbow joints experience, and while they do sell these long sweeping ones, similar to this, more like a circular angle, but they do sell longer sweeping ones, but those are DWV instead of Schedule 40, and Schedule 40 is rated for pressure and for potable water use. So I opted to use two 45-degree elbows, and then I will do, well, it's 1 3/8 to come in right here, and so I'll do 2 6/8, 1/2 PVC, 1 1/2 PVC, and then I'll combine these together. So that comes to where I'm using Christie's PVC solvent cement handy pack. I'm using the red hot blue glue and the purple primer. I'm also going to be using these ball valves, these Schedule 40 ball valves, for the slip, and I took the liberty to get a jigsaw, which will make cutting the barrel lids open more easily, and I also got a hole saw set. I'm primarily going to be using the 1 1/2 inch size, because my piping is 1 1/2 inch, but I also plan on using either the 4-inch or the 6-inch hole saw cutting tools to cut the top piece of the lid off for the radial flow settler. I also purchased a ratcheting pipe cutter for cutting PVC pipe, and that also came with an included deburrer, which I know I'll use. I was thinking of just using a handsaw, but I didn't want to deal with deburring as much. So these two barrels are rainwater collection barrels, 55-gallon rainwater collection barrels that I found at a yard sale in my neighborhood. They were actually $5 each, and this tool to pry open these, the holes were also, this tool was also $5, which is a great deal. But I plan on using this barrel as the radial flow settler barrel, and this one as the sump tank barrel. These are definitely oversized for my 100-gallon system, but I would rather be oversized than undersized, and more volume doesn't hurt, so that's good. So in order for the height of the tank and the water barrels to be the same, I've purchased some cinder blocks and these 2-inch slabs that I'll use to raise up the stock tank by 10 inches, and I'm going to load these and put them into the tank, or on the ground, so then I can put them onto the tank. So as this sped up clip is playing, I'm just going to elaborate as to why I needed to elevate the tank. In order to maximize the efficiency of this system, I need to make sure I have the most amount of water possible in these barrels, which will allow for a higher retention time. And since this is all gravity fed, I'm not pumping any water in. It's the water levels are equalizing. I need to make sure that they're at the same height, and elevating the tank will do so. So now that the tank is in, you can see that the approximate height is the same, but obviously the hole for the solid lifting outlet or outflow will come around here, so the height of the pipe that comes up would be around here. But that makes sure that the water level in the radial flow settler is high enough. So an important design consideration I took was the placement of the pond due to the amount of sun exposure I'd like to have. I'll have some plants, aquatic plants, that'll be in the pond, and they'll need a certain amount of sun exposure, but I didn't want complete sun because of overheating and excessive algae growth. In my previous placement, there wasn't enough sun. It was placed in the rear of my house, so there wasn't enough sun, and the water would drop to maybe the low 50s. So in this placement, I have the sun just coming around halfway through the pond, which will keep enough sunlight for the fish and the plants, while also protecting it from rain and leaves and all those type of things. And I'm good, happy with this placement.